Hello, this is James and Dan's wireless project, assignment 2. This is talking about how this topology has been set up and how we configure it. We have, at the edge of our network, we have got ZenTL. This is connected to the internet, and on ZenTL we have an access control list, VPN, firewall, and NAT configured on it. This is then connected to a Cisco router.
The Cisco router is for our internal routing. It's connected to a switch. It has it's set up for route on a stick for the VLANs, so they can route between them. On the switch we have VLAN set up, VLAN 10 for wired, VLAN 20 for wireless, and VLAN 30 for VPN traffic. This separates the different clients. Connected to the switch we have an Cisco access point. On the Cisco access point we have access control lists to stop wireless clients from being able to ping internal network clients, wired clients and so. Only HTTP traffic is allowed on the access point, as well as the traffic required for authenticating via Active Directory, which is done with Windows Server 2008 as a radius server and the access point as a radius client. And then we have an Ubuntu server connected to the wired network, which distributes IP addresses via DHCP. It's set up for different scopes for the different VLANs. Each VLAN has its own IP address range, according to VLAN. So VLAN 10 has 192.168.10, and VLAN 20 has 192.168.20, and so on. And we have a TFTP server on the Ubuntu server for distributing and backing up settings from the Cisco devices. We have an Apache 2 server on the Ubuntu server as well for an internal web page. This is ZenTL, which acts as our router and firewall for the system. Here we have the access controls for websites and such. The threshold set to very strict, which blocks sites such as pornographic images and spam and virus websites with malicious content and so. We can also manually add websites that we wish to block. As you can see, facebook.com has been blocked here. If you wanted to quickly allow access again, we can simply run the actions, and we can change that to always allow, or we can simply press the delete button and people will be allowed to go straight back onto Facebook.com. We also have a firewall configured for the external. And we have certain internal rules as well to protect the network. You can see the different IP addresses. We've got an external WAN interface on ZenTL, and we have an internal interface which connects to our Cisco router. We also have a VPN set up on ZenTL, which allows us to access the internal resources and use the internet from this system on other systems over the internet, securely and encrypted. We use certificates for this. Clients get their own certificate, which can be downloaded by going to the download client bundle, and then you can distribute this to systems. If you use the OpenVPN installer, it's all set up and configured for you, which is quite helpful. This is the Windows Server 2008 system. It is using Active Directory and acts as a radius server to enable us to authenticate clients from on our Cisco access point using 802.11 enterprise PEEP. We have two users. One is James. And I'll just quickly show the radius. Using network policy and access services. And under that we have NPS. Here we have the radius clients. .25 is the address that the access point gets.
This is our Ubuntu server. On the Ubuntu server we have DHCP, TFTP and Apache 2 configured. On screen currently is the DHCP server. As you can see, we have two addressing schemes, .20 and .10. This allows for the wireless for the traffic to be separated between wired and wireless. We have .192.168.10.0 for wired traffic and 192.168.20 for wireless traffic. We also configured a TFTP server on here. This is to allow for upload and download of configuration files from the Cisco devices.
This is a demonstration of a wired client connected through the switch to the network. As you can see, it has a 192.168.10 address and the specific DNS is securenet.net. And we'll just show accessing a website, show the internet works. Facebook should be blocked if we spell it right. As you can see, Facebook is banned by the network policies shown before. Now we will demo connecting to our wireless. As you can see, let's connect. We're asked for extra details. This computer is already set up to know that it's 802.11 enterprise PEEP. And our username and password for this user. And once we press enter, it will authenticate against the radius server. And as you can see, we're signed onto the wireless. Just have a look at the settings. You will see that we have a .20 address, which is different to the .10 address of the wired clients. As you can see, the home page loads fine, and we will test the filtering rules. Also apply to wireless. Google works as it should. Now we'll try Facebook, which should be blocked. As you can see, the network policies still apply and Facebook is blocked. And now we will test ping, because we have blocked all traffic except HTTP and the stuff you needed to authenticate via the radius, so ping should not work. As you can see, ping hasn't worked. So we know that our access control lists are working.
Now I'll be showing you the VPN aspect of our network. As you can see, we're trying to connect to 192.168.10.3, which is the address of our Apache server, and it's currently not working. But as soon as we connect through the VPN to our network, as you can see, we've got a .30.2 address, which is our VPN address range. And now we can connect to the internal network resources and the internal web page. Now we're using something called Thing app, which is available on iPod and Android, to scan our wireless network. Similar to Nmap, and it'll scan services. We'll scan 20.1, which is our Cisco router. Going to do a scan services. This will pick up things like HTTP servers, DHCP servers, and any other open ports that could be exploited over the wireless. We're using quite extensive ACLs on the Cisco router and the Cisco access point itself, so it's expected that this should be completely locked down. As expected, it finishes with finding 0 services. So the ACLs are doing their job. And now we'll quickly scan the access point itself, which is located at 192.168.20.26, as you can see there. This is a Cisco access point. There's ACLs applied directly to the access point, so this should also pick up 0 services. And this scan has finished again with 0 services found. So that's the access point and the Cisco router completely secured with ACLs. No ports are open to be accessed or anything. And you can see it was connected to SecureNet AP.